everyone to another webinar from SPX Flow. In this case, we have called this webinar Unlocking the Hidden Treasures of UHT. In the webinar, we will try to spot ways to save energy or become more efficient. Obviously, those savings have an impact on the bottom line of your company, and those savings in today's world of high inflation and crazy prices of electricity and gas are really treasures. So before we get started, I'd like to walk through a few housekeeping items. This presentation is being recorded. Your camera and audio have been turned off. However, the chat and the Q&A functions are enabled for you to submit questions and comments. I will try to answer all of your questions at the end of the presentation. And lastly, I'd like to ask for your help to complete a brief survey at the end of the presentation. So this will help me to improve the quality of our content and will give you an opportunity to voice your opinions as well. So let's get started. My name is Serafin Garcia. I'm based in Madrid, in Spain. I'm working as the EMEA Technical Sales Manager for UHT Systems. I also have the ownership of script surface heat exchangers, and my background is in agricultural engineering and also in thermal calculations. I joined SPX Flow in January 2019, and prior to that, I worked within the food and beverage industry for suppliers as well. Right, so let's have a look at the agenda for today. So we will talk about those hidden treasures. We will briefly talk about the history of APV UHT systems, different types of efficiencies, a bit of theory, and we'll try to go a bit deeper on what treasures we can find within the direct and indirect systems. So as we move through today's presentation, we have identified several areas that we're calling the hidden treasures of UHT technology. So look for the green coin, as you can see in the slide, throughout the presentation, because we will be identifying some of those hidden treasures, representing areas like cost savings, efficiencies, time savings, and many more things. All right, so just a brief comment on the history of APV systems. So at the end of the 19th century, we got the first pasteurization units, then APV, which is an acronym of aluminium plant and vessel. It invented the plate heat exchanger. That was in 1923. Later, in 1949, we have the first UHT systems based on tubular heat exchangers. And then we move into what we call direct methods, which are injection and infusion systems. So these later ones were released in 1966. 20 years later, great year, I was born, and some years later, APV patented the instant infusion, which is a system that we typically use for viscous products, like baby food or whey protein concentrate. Then we have the high heat infusion that we are typically using for high resistance spores. And finally, we have the Infusion Plus, which is our latest solution for which is today a very popular type of drinks. We're talking about the ESL drinks, or the extended shelf life drinks. And finally, in 2022, as we are today, essentially we keep looking for ways to improve the reliability of our systems. We keep searching for ways to reduce the utility consumptions and enhance the OPEX. And also we keep searching for ways to run longer productions and boost the production capacity of your plants. Right. So we moved into a new block of efficiencies. So basically, we can find efficiency in a variety of different places. So we have divided those into three main blocks. So in the first block, we have the production efficiency. So we look at things like how we can run longer, or how much time do we need to clean, what ingredients and what concentration of those ingredients we have to use. Then we have the waste reduction, where we look at the possibility to use less chemicals, less water, and obviously try to minimize as much as possible the product loss. And finally, we have the energy efficiency, where we try to look for ways of saving steam, electricity. We look at ways to boost the regeneration efficiency in our plants. So we try to reuse energy in different parts of the plant. And finally, the higher hygienic standards, where I would say, thanks to our expertise, we can guide you on how to be more efficient energy-wise, highlighting some of the features and the NPDs that we can introduce into both existing plants and obviously into brand new UHT plants. So regarding the production efficiency, I could say that since we start with the production until the product reaches the supermarket, we're looking for ways to increase the efficiency. So here we have some of the questions that we might need to ask ourselves in order to find more efficiencies within your systems. So those things could be maybe questions like, okay, so what ingredients are we actually using to produce our products? What sort of proteins are we putting into our milk or into our yogurt? How can we actually stop the denaturation of those proteins? How could we use UHT systems on like media sterilizers, for example? In the field of breweries, an example would be boiling worts. That is a typical example. But all in other industries, we have other fermentation applications where we're trying to set the ideal conditions for the yeast to consume those sugars to create a broad variety of different products. We talk about new formulations, not only for beers, obviously, but other products like could be alternative proteins, like different fuels, or like vaccines, all sort of different products. Other questions related to the production efficiency could be how long can I run before cleaning the system? For how long do I actually need to clean my system? Other things could be things like how severe is actually my fouling, or is it really my product naturally fouling, or is it like something else in the product that is making my product to fall? Am I going to be running for only an hour or 2 hours, or can I have like a production cycle of 30 hours before I need to clean? Then on the waste reduction part, we have to ask ourselves questions like how we can actually reduce the waste. So anything that we're actually putting in the drain is a loss. And those are typically products that we have already paid for them. And so obviously the aim is to reduce as much as possible that waste. When we're running a UHT system, there are transitions where we're moving from production into cleaning. And in those transitions, we're losing product. So obviously our intention is to minimize as much as possible that, and obviously to decrease the time that those transitions are taking. In the UHT, we are using steam especially, for example, in the direct methods like injection and infusion. And also, for example, when we're considering the vacuum vessel, we have vapor coming out. So is there a possibility to do something with that vapor? And we actually maybe use it for doing like a pre-rinse in a cleaning cycle, or could be using that vapor as condensate in order to preheat the incoming product in our plug heat exchanger or in a tubular heat exchanger in our UHT installation. And finally, we have like the timing of the CAP. Obviously, we have to clean our installations after the production. So our aim is to minimize the number of CAPs needed, and also to minimize the duration of those. So we can have longer production times, and we can save on the CAP chemicals, on the caustic, on the acids, and obviously on the water as well. And finally, what about energy? So especially what about steam? So you know that in our direct methods we are using culinary steam. So we need to think about how much steam do we actually need. What is the actual pressure that we have to provide to the system in order to get the sterilization temperature that we are aiming for. But also we have to ask questions like, okay, with that steam that we are using, is there any possibility to reuse that steam in a different way, or with the vapor that we are getting out of the vacuum vessel? Is there anything that we can do with that? Or things like, would we regenerate that steam in a different way? Or could we potentially be insulating our equipment in order to stop that energy loss? So essentially with SPX Flow, we've been developing solutions where you can reduce that energy loss and also cut the energy on the air conditioning to reduce that the temperature within the factory. So at the end, it's like a kind of win-win situation, because solving one problem, you are saving energy on the other one as well. So you just need to insulate, so you are not losing that energy. But at the same time, you are saving energy because you don't need to actually switch on the air conditioning. In the UHT system, we have always a combination of temperature and time. So we have seen installations where the holding tubes were quite large. That means higher pressure drop, and you might also consider insulating that holding section in order not to waste energy, and that obviously requires more space and even higher costs. So we can do a number of different calculations to precisely calculate the holding section by mathematical modeling, and also by running tests in our innovation center, both in Singapore, in Denmark, and also in Dubai. So we can do the lab measurements, calculations needed to guarantee that we can hit the KPIs that we have agreed. And sometimes the customer doesn't have the space or the budget to have an increased boiler capacity. So we need to look at ways to minimize that production of steam. That can help a lot because we can also, for example, save on fuel to heat the water to generate steam, and also we can find savings in the energy needed to actually distribute that steam from the boiler into different parts of the plant. So essentially, we are always looking for ways to recover and to use that steam or that condensate somewhere else in the plant or in our UHT system without having to increase the capacity of the boiler or having to go for like a new one. Right. So a little bit of the theory of operation. So I would say that in the thermal processing technologies world, we have two main definitions. Those are the pasteurization and the sterilization. So in the pasteurization, we are aiming to eliminate pathogenic bacteria. However, the thermoresistant bacteria would survive. Also, we have to keep into consideration that a pasteurized product like milk could require refrigeration. On the other hand, with sterilization, we understand the process where we try to eliminate all of the microorganisms. However, in the industry, we often talk about commercial sterilization, as we never achieve an absolute sterilization. So that actually means that the product is not necessarily free from microorganisms, but those that remain will not spoil the product during the distribution and during the storage. Another benefit is obviously that distribution and storage, we can do it at ambient temperature. So that is a great benefit because we can save on the logistics, on the warehouse, because we don't need the cold chain. So we can also find new markets, as we are talking about like a shelf life that the product is now 3-6 months, even like a year. So we can actually put our product in the other side of the wall if that is our intention. And finally, an interesting scientific fact, which is that is actually the base for our latest development on our Infusion Plus technology. And that scientific fact is that the speed of reaction by temperature increase is much faster for germ destruction than for chemical reaction. Okay, so that actually means that we are very efficient destroying microbes by applying high temperatures without actually destroying the organoleptic features of our. So when discussing UHT systems, we can distinguish between direct and indirect UHTs. So in the direct UHT, we have a mix between the culinary steam and the product. And we can distinguish between infusion and injection. So in the infusion, we have the product going into steam. And in the injection, we have the steam going into the product. And then we have separately the indirect technologies. Okay, so in these type of UHT systems, there is no mix between the steam and the product, and the heat is transferred from one fluid to another across a thermally conducting barrier like the metal wall that you can find in a plate heat exchanger, in a tubular, or in a scraped surface heat exchanger. So within the range of thermal processing technologies, we can mention three main solutions. Those are pasteurization, extended shelf life, and UHT. On those, we can also highlight the low pasteurization that we typically run at 72 degrees and 15 seconds. So this is the high temperature short time. Then we have high pasteurization that we can run at 85 degrees for 15 seconds. And this is the typically process that we tend to do, for example, with cream pasteurizers. And all of these pasteurization options are giving us a shelf life of around a week at 4 degrees. Then we have ESL, so that is extended shelf life, where we are reaching temperatures of about 130, 135 for half a second. We have different process conditions as well, because we can highlight already the Infusion Plus, where we can reach temperatures of 157 degrees for like 0.9 seconds. and that would give us a shelf life of 45 days at that maximum temperature of 10 degrees. Okay. And finally, we have our comprehensive range of UHT solutions with both direct and indirect technologies, where we can achieve a shelf life of 3 to 12 months, where we don't need the cold change. And you see here the green coin. We can distribute and storage, as we mentioned, at ambient temperature. And for that purpose, we can actually use our whole range of different technologies, as you can see listed, like injection, infusion, plate heat exchangers, tubulars, and screws. We move now into like a new block where we are exploring the difference between indirect and direct. So here we can see a generic schematic of UHT system based on plates. So essentially, we start with the production in the balance tank. If we are considering, for example, milk, it could have a temperature of around 5 degrees in the balance tank. Then we do the preheating up to 75 degrees. Then we can go into, for example, the aerator that isn't showing in the slide. Then we can go into an upstream homogenizer. After that, we keep heating in the plate, and then we go into the protein solidization cell. We typically do that at around 90 degrees, and here we have the denaturation of the proteins. So our intention is to do that in a holding cell instead of fouling our plate. After that, we can hit the solidization temperature. Could be around 140 degrees, for example, and we can hold it for several seconds, 1 to 4 seconds. It could be more depending on the product, and then we start cooling down. We can actually achieve here direct regeneration by going into the first section of the plate heat exchanger, so we can use the already sterilized product to preheat the incoming raw product. We also have a closed water loop where the water that gets cooled down is used afterwards to do the final cooling. So given the current measures, we can achieve like high energy recovery. Plate heat exchangers are extremely efficient, so we can reach up to 93, 94 energy recovery efficiencies. So that is pretty good. Also, some of the benefits of the plates could be that they are quite cost effective in terms of capex and opex. They are operator friendly. We have like a flexible product range and different temperature profiles that we can run in just one unit. And all of our units are pre-assembled and factory tested, and also the plate heat exchangers are typically quite a compact solution, so the space required in the factories is quite low. Then here we have the generic schematic of a UHT system based on tubular heat exchangers. As you can see, it is exactly the same as the plate. We have here one unit, which is actually another tubular unit that is providing hot water for the final solidization temperature. And also we have a closed water loop where the same water that we are using to preheat the system will be getting cooled down, and that is the water that we can actually use for the final part of the cooling. In the tubular UHT system, we can also achieve longer running times, and those are possible, typically longer than the ones that you can get in plates. The issue, I would say, is that the product hold that volume becomes significantly larger in these plants, especially if we're talking about high capacities. And obviously, these could be affecting negatively the quality of the product, because that product would be held at longer high temperatures, so there would be like a thermal stress on that product. Obviously, one of the advantages that there will be no problem when you want to run particles or fibers. That is actually one of the highlights of the tubulars. And regarding regeneration efficiencies, those are less efficient than plates, but still we can achieve good regeneration efficiencies, maybe within the range of 75 to 85%. In terms of costs, typically they are slightly higher in comparison with like a plate UHT system. And the reason is because the tubulars are not that efficient, so not that efficient thermally. So we have to compensate it with more transfer area. So that means more material, more tubes. So that is obviously having a more negative impact in terms of like higher cost and also the overall higher pressure drop that you can expect in a tubular system. This could be the schematic of a typical UHT injection plant. So the product is sitting in the balance tank at around 5 to 7 degrees. Again, we continue with the example of milk, and then it will be pumped into the preheating section. In this case, a preheat exchanger where we can reach temperatures of about 75, 80 degrees. Then the product goes into the injector, where it reaches the sterilization temperature, let's say around 145. Farther down, it goes into the holding section, back pressure valve, and then into the vacuum vessel, where the vapor is flashed off. And as a result, the product temperature goes down, and we can actually use that removed vapor. We can condensate that vapor, and we can actually reuse that energy on the preheating step that we have in the plate heat exchanger. Afterwards, the product goes into the aseptic homogenizer, and then back to the plate heat exchanger, where we can complete the cooling of the product. And finally, the product can go directly into the filler, or we can aseptically store the product into a sterile tank. And here we can include some pieces of equipment. We can, for example, mention the non-aseptic cooler, which is based on tubular heat exchangers. So essentially, when performing CIP and pressurization, we can save a lot of energy. So there you have the green coin. And obviously, this is also like a convenient solution, because we can also save or we can reduce the load on the cover water. So there you go with those green coins, both in the condenser after the vacuum vessel and also in the non-aseptic cooler. You have the same benefits or the same possibility in order to save energy in the infusion system, which is the system that you are seeing now in the slide. And in this generic schematic, we can see how the product is sitting on the balance tank, again 4 or 5 degrees. We can pump it by means of the centrifugal pump that you can see in the diagram. We can do that in a plate heat exchanger. We can raise that temperature. We do the preheating typically on a plate heat. We can also do it in tubulars if that is the preferred way of the customer. And then we typically achieve temperatures of about 75 degrees. Then the product goes into the infusion chamber, which is essentially the main difference in comparison with the injection system. And this is where the magic happens, let's say. We are infusing the product into the steam. And it is during the fall of the product within the infusion system, during the infusion vessel, where we get into the sterilization temperature. After that, we have the extraction pump sitting below the infusion chamber. And here we are actually pushing the product into the holding section. From that, directly into the vacuum vessel, where the steam that we have put into the infusion vessel, it will be flush off. That vessel is working on the vacuum, and as a secondary benefit, we get the temperature of the product going down. After that, typically we tend to go a couple of degrees lower than the preheating system. In that way, we can guarantee that all of the steam that we put into the infusion vessel, we have actually take that out, and we are not diluting the product. So after that, we can just go into the aseptic homogenizer and then back to the plate heat exchanger to do the final cooling. Let's say 20, 25 degrees. And after that, we can either go into the filling machine if the filler is ready to work, or we can go into the aseptic tank. Right. So to understand how effective a UHT treatment is, we typically use a couple of factors to understand this effectiveness of the UHT. And those factors are what we call, or what is called in the industry, B star value and C star value. And we are trying to understand the interrelationship of those two in this graph. So firstly, we have to understand what they mean. So the B star value is the bacteriological effect, or the bacteria kill rate, and it is also called this let's say bacteriological effect, in the sense of how efficient we are being killing bacteria. Okay, so that is what it means. And essentially, the bacteria count has a great impact on the shelf life of the product. So in order to be able to quantify how effective we've been with the UHT process, we are typically considering a B star value of 1. Okay. So the B star value is the assumption that the commercial sterility is achieved at 135 degrees and 10 seconds. And that would give us a B star value of 1. Okay, so at the end of the day, B star value is an equation, and we can plug, let's say, those results into this graph. So here we can see now the green line. So that means a B star value of 1. So that means that our product is safe to be consumed. Okay. Then we have C star value, and the C star value is a measurement that we are using to quantify not only the changes to taste or flavor in the product, but also to measure the level of degradation of vitamins and changes into the proteins. Okay, so the C star value is based on conditions for a 3% destruction of thiamine, which is the vitamin B1. Okay. And that requires a temperature of 135 degrees for 30 seconds. So there you go. That is the red line, and that is a C star value of 1. And the intersection of those lines are giving us the UHT region. Okay. Then outside, we have the autoclave region. You can see that is to the right-hand side of the green light. So that means that is safe to be consumed, a product which has been treated in an autoclave. But you can see how far away is from the red line. That means that the quality of the product that you can expect is pretty low. Then, as I mentioned, the intersection of those two lines are giving you the UHT region. And then you have the indirect and the direct system. You can see how the indirect system is to the right-hand side of the green light. So the product is safe, but is quite close to the red line. So that means that the quality of that product is not the best. We want to be as much as possible away from the red line, but being within the UHT region. So you can see how the direct systems are actually complying with those premises. Then outside of the graph, you have pasteurization at 70 to 80 degrees. It is outside because in the graph we're starting at 100 degrees. And then you also have Infusion ESL and Infusion Plus. Right. Okay, here we have a table where we are trying to do a comparison between different UHT types with the same B star value. So we have different spore kill rates and especially different chemical impact. So here you can see another coin. And the reason for that is that you can see that the Infusion Plus, which is having process conditions of 157 degrees for like 0.09 seconds, gives you a total beta-lactoglobulin denaturation of 6.3% only. Okay, so virtually you are not destroying anything of the beta-lactoglobulin. If you compare those results with other technologies like injection or tubulars, you can see how those values are much higher. In the tubulars, you are pretty much denaturating all of the beta-lactoglobulin. Also, you can see as well on the right-hand side of the table the leasing losses. Those are virtually inexistent, especially on the Infusion Plus, only like 0.03%. And this is one of the essential amino acids for humans, and that has to be obtained from the diet. And typically, milk is a good example because it's quite rich in this amino acid. Then here we have just a slide showing some of our UHT solutions. SPX Flow is specialized on skidded pasteurizing systems and also all the range of different UHT systems, from like very simple, let's say, standard systems to like really complicated tailor-made systems. I would say that our portfolio is quite comprehensive. One of the most comprehensive in the world, because we can actually pick the right technology from our portfolio based on the specific conditions of a particular project. It's not that we only have one technology and we have to take that technology always. But obviously, I would highlight our infusion systems, our injection systems, and our pilot and combi plants. And we are calling combi plants to those solutions where we are combining in the same line different technologies in order to provide as much flexibility as possible to our customers. All right, here we have more coins, more green coins, and we have a comparison between the different running times that you can expect in different technologies. So this is actually for milk. And you can see that we can achieve the longest running time on the Infusion ESL in between CIPs. Also here we have a comparison with the chemical impact. So we can see how the infusion system, the C-star value is pretty low. So that means that the quality of the product is very high, is pretty good. We typically are using the infusion for like premium quality products. And that is because we have not stressed thermally the product. We can see how the values are higher in other technologies, and therefore the quality that you can expect is much lower. And that is typically what is happening in other systems like injections or like especially indirect systems like plates or tubulars. Then, in terms of regeneration, we have that the most energy efficient are plates and tubulars. That is why we have launched a number of different NPDs and solutions into the market, as we can see, as we have seen in the presentation, like hibernation mode, insulation, non-aseptic cooler, different condensers. Because we want to tackle this challenge, and we want to increase the regeneration efficiency on those systems as well. At this time, we are actually working on new NPDs and new ways to improve those systems in terms of like energy efficiency. And we're doing some field testing. If those tests are positive, we will be in a position to be launching those new NPDs in the next few months. So we are quite excited about these new projects. Then for higher beta, like to global in levels, we have to go into infusion systems, as we saw in that table before. If our intention is to preserve those high levels of those whey proteins. Other systems, you would find a lot of issues or problems with the denaturation of those proteins, and hence, obviously, the nutritional value that you can expect from those products that has been treated in different technologies like tubulars or plates is pretty low, as you can see on the slide. Then we move into lactulose, which is a temperature time indicator. So when applying a thermal treatment to our product, this is one of the indicators, especially for like Maillard reaction. So essentially, you start altering the taste, the color, texture of your product due to the caramelization of those sugars. So obviously here, the lower the lactulose level, the better it is. So UHT methods like infusions are the best one for keeping lactulose level under control to the minimum. Also to be within what the European legislation is forcing you to do. Here we have just a summary of some of the benefits in our direct UHTs. So this is just a recap. We can include the top condensers to reduce energy after the vapor which is exiting the vacuum vessel. We have the non-aseptic cooler to recover energy during the CAP and pre-sterilization. We can insulate both the infusion vessel and the vacuum vessel. We can run in this hibernation mode after CAP and sterilization. We can also include a number of different improvements in the distribution nozzle and also in the extraction pump in order to reduce the fouling and therefore increase the production run. So we can include a number of different benefits and features in order to increase your operational efficiency, the production time, and also the OPEX. Also, one interesting one is that we have the possibility to install a high definition camera inside of the infusion vessel to see what's going on in real time. And we can perform what we are calling the just-in-time CIP. We can also include in our automation packages the possibility to log and monitor F0 values. So let's say that every single time you can see what is going on in your system, and then you can react to that by diverting the flow if you are not, let's say, targeting the sterilization temperatures that you want. And then here we have a recap for the indirect UHTs. Obviously, we can find a good value on the regeneration efficiencies that we can get in these technologies. We can recover a lot of energy, so the OPEX is very low. That is quite attractive. So that means that the total cost of ownership is also lower than indirect systems. Also because the CapEx is also cheaper in systems like tubulars or plate heat exchangers. Also on tubulars, we can achieve longer running times in comparison with plates, with pretty low maintenance costs, as typically those installations, the tubulars are quite robust, and no worries typically with spare parts, especially if we are talking about a fully welded tubular heat exchanger system. That was the end of the presentation. So thanks a lot for attending this webinar. we can move now into the Q&A session. But also, let me know if you have any queries, and maybe you don't want to raise the question right now, and you prefer to have like a one-to-one conversation separately with me. Feel free to contact me using my contact details. You can drop me an email, or you can give me a call. You have my contact details again in the slide. And don't forget to take the survey at the end of this presentation. I would really appreciate your feedback and whatever questions you might have. So if at the end of this session there are some answer questions, maybe I don't have right away the answer for you, I'll have a chat with my team, and then I'll contact you back and provide the answer for you. Okay, so we move now into the session, and thanks a lot for your attention.
All right, so hopefully that was useful. So we can now start with some Q&A session. I can see already some questions. Okay, so Peter was asking about the flash vessel, if that was working on the vacuum. So yeah, essentially, Peter, good to see you, by the way. Yes, we have the flash vessel working on the vacuum. So essentially, we are decreasing quite a lot the pressure. And as a consequence, we have the split between the product and the vapor. As a consequence, we are also cooling down. So we have like two benefits out of the flashing vessel. In one side, we have the separation between the vapor and the product. We have the product coming down by gravity, and then we have the vapor going to the vapor duct that we can recover with the condensers. And the second benefit is that as we are working at the vacuum, we have also the product being cooled down. All right. Then also we have, I believe, more questions in the chat. So then, yes. So do UHT systems come in standard sizes, or is each quote and installation a customized job? So essentially, we are providing tailor-made solutions. So one of the benefits of working with SPX Flow is that you have the benefit of working with a provider that has a comprehensive solutions of UHT. It's not that we only have one solution and then we have to offer that solution only. We can pick the right solution, and then we can tailor it, we can customize that solution. So we don't have to offer anything which is extra or like optionals that the customer is not really interested in having. So yeah, every single solution is tailor-made for the real needs of the customer. Yes. Okay. Right. Yeah. Yeah. Exactly, Peter. Yeah, I mentioned also about the flashing vessel during the presentation. So yeah, essentially that is how it works. And then we have another question, which is if there is a design center in Europe and where it is located. So yes, we have two design centers. in Europe. The main one is in Denmark, in Silkeborg, where we also have what we call the Innovation Center, and we also have a lab. We have the second main design center in Czech Republic, in the office in Brno. So yeah, we have those two design centers, and overall we also have those two innovation centers. One, as I mentioned, in Denmark, in Silkeborg, where we can run some trials. And we also have the lab capacity. So after running those trials, we can analyze those samples. And we have the second main innovation center in Dubai, in Emirates. So those would be, let's say, the two main ones for the EMEA region. So for Europe, Middle East, and Africa. All right. Okay. I believe that was the final questions. Okay, we have another one. It looks from Peter. So regarding the production capacity, is possible to categorize what capacity is convenient to correctly categorize the opportunity? Yes. Well, obviously, one of the main things that we have to take into consideration when sizing the system is actually the capacity. So we have quite flexibility designing those UHT systems. Depending on the technology, we might have a limitation, especially if we talk about really high capacities. But even on to, let's say, injection and infusion, where we could be more limited by the capacity, still we are able to reach capacities of like 35, 40, 45,000 liters an hour. And then on the lower level, we're going to start with the pilot plants that we have 80 to 100 liters an hour typically. So those are, let's say, the typical units that we are using in order to assess the application, to find out what would be the right technology for that capacity. So then we can scale up into the industrial plan with the guarantee that the application and the technology that we have selected is working properly. So yeah, hopefully those questions were answered. Any other question at all? If not, as I mentioned, also during the presentation, you have my contact details. So feel free to give me a shout. You can ring me up, or you can drop me an email, and then I'll try to help you out. So yeah, remember, I'm your UHT man in the region, in the EMEA region. So yeah, if you have queries, or if you are already discussing an interesting project with your customers, so yeah, please involve me. I'll be happy to support you. Right. So if there are no further presentations, I think I will end the presentation. And please, I remind you that after the presentation, there will be like a short webinar, a short survey. So a few questions. It will help us to identify if we are doing a good job or not, or if we can always improve. That is positive for us. So guys, you have a good day, and yeah, take care. Cheers. Bye.